an internal OpenAI reasoning model has made a historic breakthrough in mathematics by disproving a famous conjecture first proposed in 1946 by Erdős. This is the first time an AI has settled a major open problem in the field. The conjecture in question is known as the unit distance problem, which asks how many pairs of points can be placed exactly 1 unit apart in a plane. For over 80 years, mathematicians had assumed that a square grid layout offered the closest approximation to the optimal configuration. But the OpenAI model found a new and more intricate pattern that beats the grid's efficiency, using algebraic number theory to achieve a structure no human had previously pursued. The result was verified by a panel of external experts and has already sparked further refinements from researchers like Will Sowen of Princeton, who improved the bound on how many unit distances can exist. The original proof showed that the number of unit distances grows at least as fast as n to the 1.014 power, which is a polynomial edge over the grid-based bound. However, the upper limit still remains near n to the 1.333 power, leaving a gap that remains unsolved. This achievement marks a significant shift in how AI can contribute to mathematical research. Unlike most people arrive after the move is obvious and the easy upside is gone. We focus on serious crypto education and high-quality signals before the crowd rushes in, so you can understand the setup earlier and move sooner. If you want that edge, visit the link below now. Earlier AI-assisted proofs that were either trivial or heavily guided by human input, this result was produced autonomously and stands on its own merit. Tim Gowers, a Fields Medal winner, described the work as a landmark in AI-assisted mathematics. He noted that no earlier AI proof had come close to this level of originality and impact. Daniel Litt of the University of Toronto similarly called it the first AI result he found genuinely exciting on its own terms, not just as a sign of future potential. The breakthrough is particularly notable because most mathematicians had spent years trying to prove the Erdős conjecture, not disprove it. The model's approach was novel and unexpected, suggesting that AI may now be able to explore mathematical spaces in ways that humans have not considered. The result has also raised questions about the role of AI in mathematical discovery. If AI can find solutions to long-standing problems, what else might it uncover? And how might this influence the way mathematicians approach their work in the future? The next signal to watch is whether other conjectures will be tackled using similar AI methods, and whether the mathematical community will embrace AI as a legitimate collaborator in research. For now, the proof stands as a milestone in the intersection of artificial intelligence and pure mathematics. The mechanism behind this breakthrough is rooted in the model's ability to process and analyze vast mathematical structures in a way that traditional human methods could not. By leveraging algebraic number theory, the AI was able to construct a configuration of points that maximized the number of unit distances, something that had eluded even the most skilled mathematicians. The stakes of this discovery are high, not only because it resolves an 80-year-old problem, but also because it opens new avenues for AI to contribute to mathematical research in ways that were previously unimaginable. The fact that the result passed external review and most people arrive after the move is obvious and the easy upside is gone. We focus on serious crypto education and high-quality signals before the crowd rushes in, so you can understand the setup earlier and move sooner. If you want that edge, visit the link below now. Was refined by human experts like Will Sowen underscores its credibility and significance. It also suggests that AI and human collaboration can lead to even greater insights. What's next? Mathematicians and AI researchers will likely look to apply similar techniques to other long-standing problems, testing whether AI can consistently produce novel and impactful results. If this trend continues, it could redefine how we approach mathematical discovery, shifting the balance between human intuition and machine computation. For now, the OpenAI model's work on the Erdős conjecture stands as a powerful example of what AI can achieve when given the right tools and the freedom to explore uncharted mathematical territory.